Okay, so for this question to be answered, you need to know that the formulas that needs to be used. So let me just give an example of the formula. The first formula right here is f of x is equal to a naught plus the summation from n is equal to 1 to infinity a sub n cos n pi x over L plus b sub n sine n pi x over L. So we basically need to know this, what I've just written here. And we know that this is a coefficient. This is a coefficient right here, and this is also a coefficient. So now we also need to understand the formula to find a naught. So what is the formula for finding a naught? So the formula for finding a naught will just be a naught is equal to 1 over 2L integral from negative L to L f over x dx. So this formula is for finding the a naught, this one here, this. Okay. We also need to find let me cut here. We need to find a subscript n, which is equal to 1 over L integral the lower limit there and the upper limit. We have f over x, okay, here cos n pi x over L dx. Okay, so next will be how to find the formula for finding this right here, the coefficient, which is right here. This coefficient is for this stuff here. So the formula for b will be b subscript n is equal to 1 over L lower limit there and upper limit f over x sine n pi x over L dx. So these are the formulas we must know. Okay, we must know these formulas by heart. There is this one, there is this one right here, and this one. So these formulas must be known by heart. So let's start with the a. So the a subscript right here, we know the formula. Okay, we just copy the formula so that we plug in or we identify what we are supposed to put. Okay, so here for L we are going to put a pi. Okay, so this pi is coming from the pi we're able to see right here, like from let me put up a graph so that we see what we are getting. So this is how the graph looks. We have a pi, 2 pi, we have a negative pi, we have a negative 2 pi, and we have a 1, negative 1 here. So the graph for this question right here Okay, we will look like this. To start from here to here, it drops to here, goes there, here, just like that. Okay, not this one. Supposed to drop like this. Here, goes here, goes here, goes up to somewhere here. So it's repeating. This is how the graph looks for this Fourier series. Here, actually, here is nothing here. Okay, it's not connected. So now the period, you have been given period to be a 2. Okay, our period is a 2, and this is where the L is coming from, because we know that from here, if our period from here to here, it's a 2 pi. Sorry, from here to here it's a 2 pi, from here to somewhere here it's a 2 pi, or let me just say from here to here, where the graph is repeating. Here to here is 2 pi. Here to here, where it's repeating, is 2 pi. It's a 2 pi. Okay, so since it's 2 pi, we know that from here to here it's pi, and this is where our L is coming from. Okay, our L is just a pi. So we are going to put a pi right here. So it will be 2 pi. So these two together with the L, it will give us the period over this Fourier series. Here we know that it was supposed to be negative pi to pi. Okay, so we'll just focus on what is on top here. So we'll say from 0 to pi. So it will be like this, from 0 to pi. Okay, so this is the x. On f here, f of x, we just put a 1, and the 1 is right here, this one. So we'll just say it is dx, because 1 multiplied by dx will just be dx, minus this minus is coming from this function right here. So minus, the same must be repeated, so it will be like this. Here the limit is 0 right here. So we can solve. When we solve, we have 1 over 2 pi. Here we have x, because we are respecting x. The lower limit is 0. Here it's pi. This also will be the same. The lower limit, actually here there must be a 2 pi. This 2 pi. So when we integrate with respect to x, we have x. The upper limit there is 0. Lower limit is negative pi. So now we can plug in our values. I've factored out this. Okay, it's out. 1 over 2 pi. So we'll remain with this minus x and this right here. At this point, we can plug in the limits. So we have pi, this pi, minus 0. Okay, minus this minus, here we have a 0 minus negative pi. So at this point, clean up, we have a pi. Here it will be positive, this one positive. Okay, so it will be minus, because see, this 0, it will just be a pi, minus this, we distribute this minus, it will just be negative pi, and our answer will be a 0. Okay, our answer will be a 0. So we'll say our O is equal to 0. Okay, this is very important. Okay, so we find now our n. or A subscript n. So remember, for A subscript n, we said we are supposed to be using this formula right here. Okay, so let me copy the formula. It will be A n is equal to 1 over L, okay, that and that, f over x cos, here it's cos n pi x over L dx. So this is the formula, which is right here. Just put in this formula, so it's the one we've put here. So now we can arrange our work nicely. So we have A, okay, n is equal to 1 over pi. Remember, we said our L is a pi, so it's pi. Here we are supposed to put negative pi, but we have two stuff here, okay? So just put the limits from here to here. So it will be from 0 to pi. There's a 1. So if we put a 1 here, it won't change anything. There will be a 1. So anything multiplied by 1, it won't change anything. So we'll just put a cos n pi x over pi. We know our L is pi. And then we said the x. Here, minus, because this function has got a minus, okay? So minus, the same thing, okay? The same thing here. We have now negative pi 0. Here it will be cos n pi x over pi dx, okay? So that's what we have. Now we can clean up things. You can factor out pi if you want, or 1 over pi. If we want, we factor it out. We will remain with this. Here it will be cos n x dx. This pi and this will cancel, okay? So the pi which is right here and here will cancel. Even here and here will cancel. So say minus. This has been factored out. It's already here. This and this, they were common. So we'll remain with this and cos n x dx. Okay. Now at this point, we can integrate. So here it will be sine nx over n. The limits from 0 to pi. Here minus, we have also sine nx over n. The limits will be like that. Okay. So in case you don't know how to integrate here, you can use substitution to integrate cos nx. You can use substitution where n you let u be equal to nx. Okay. All right. So at this point, we can plug in the values or the limits, or if you want, we can even factor out the n, since n is common here and here. So we can say it will be like this. We have sine nx over pi, limits from 0 to pi. Even here, limits from pi to 0. Okay. So at this point, we plug in the limits. So when we plug in the limits, we have sine pi n. So if we put pi here, it will be sine pi n minus, we put a 0 here where x is, it will be sine 0 minus, here it will be sine 0. If we put a 0 here, it will be sine 0 minus sine negative pi n. Okay, negative pi n, even close here. So this is what we have now. Remember, this is an even function. It's an even it's an odd function. Sine is an odd function, so this negative and negative will be positive. So we can say here we have sine, okay, pi n minus 0. Sine 0 is just 0. Also here it will be 0 minus, or plus, actually this and this will give us a positive, plus sine pi n. So this is what we have now. So if you are able to see nicely all this function, whichever number we're going to put here, it will just give us a 0. Whichever number we're going to put at n here, this will just give us a 0. So meaning all these will give us a 0. So 0 multiplied by what is in front here, it will be a 0. Meaning our a n will just be a 0. This one. Okay? So that we find our bn. Remember, this formula wants us to find this, and this. So we found this to be 0, this one also 0. So we're remaining with this one here. And for this one, the formula is right here. This is the formula we are dealing with. So let me write the formula here. Bn is equal to 1 over L, limits from negative L to L, f of x sine n pi x over L dx. So this is the formula we are going to use now. So we can plug in the values. So say b sub n is equal to 1. We know our L is pi. Here it's starting from 0 to pi. Okay, here it will just be sine n pi x over pi dx. We know our L is pi. Minus, this minus here, it was supposed to be plus. Now the function here has got a negative sign, so that's why we're saying minus. The same thing, okay? So here we'll put a pi. Now for the limits, here we'll put a negative pi, and the upper limit will be a 0 of sine n pi x over L dx. Sorry, over pi here, dx. So work out things. When we solve nicely, we have something like this. Here it will be sine nx dx. This and this will cancel. Minus, okay, also sine nx dx. So that's what we have. Now here we can factor out 1 over pi because it's found here and here, meaning we'll remain with this. Okay, so since we have factored out here, we can say, or we can integrate here. The pi, the 1 over pi is outside, and we have a negative, because we know the integral of sine is negative, cos nx over n. The limits 0 to pi. Here we have a minus. Okay, we have a minus already, and the integral of this will be minus cos nx over n. The limits from negative pi to 0. Okay, so this is what we have. Okay, so now at this point we can factor out the n, so it will look like this is equal to 1 over pi n. This n has been factored out of negative cos nx pi 0 plus this and this will give us a plus cos nx. The limits are from pi and 0 there, so here we can clean up our work, or we can plug in the limits. So when you plug in the limits, here we have a negative here. We can factor it out, so that we say pi n. I've put this here, okay, pi right here, minus the lower limit cos 0. Okay, so we're done there. Here you can say plus the upper limit is 0. When we put a 0 here, it will just be 0 like this, and here it will be 0 like this, minus here we have cos, okay, of course, pi n. Okay, so we can clean up our work. We have 1 over pi n. Here it's negative cos n. Okay, negative cos n, cos pi n, sorry, plus this negative and negative will be a positive 1, because cos 0 is 1, minus here it will be, oh sorry, it's a plus here, it will be a 1. This is a 1, and this one will be minus cos pi n. Okay, so we are moving. This can be added, or these two can be added. It will be 2 minus 2 cos pi n. These two can be added, and this and this can also be the same. So here, if we want, we can factor out a 2 outside the brackets. We remain with a 1 minus cos pi n. Okay, so this is our b n. Okay, so now we can test when b is even. Okay, we want to test when b is even. Oh, sorry, n, when n is even. When n is even, meaning here n maybe is 2, 4. So what answer are we going to be getting here? We'll be getting a 1. So it will be 1 minus 1, of which our b will be 0 if n is even. So we try n is odd. It's an odd number. So it's an odd number. It will be giving us what are we going to get? Negative. Okay, it will work. Okay, so when n is even, it will work. So we'll say when n is odd, so for odd it will be 1. When b is 1, what are we getting? When when n is 1, b1, for b1 here, n is 1, meaning we put 1 where n is. So we have something like this. Here we have 1. This one, when it's 1, it will be -1. So -1 will give us a negative, and negative will be positive. So here it will be 4, because this is 2 times 2, it will be 4 over pi. Okay, so let me just list them so that we see what we are talking about. We have found our bn to be equal to 2 over pi n 1 minus cos pi n. So this is our b. So now we need to find b1, because we said it's working with odd numbers. b1, b2, sorry, b3, not 2, b5, we are dealing with odd numbers, b3, yes, up to, and so on and so forth. So for b1, we found it to be 4 over pi. b2 also be 4 over, b3 over 3 pi. This one will be 4 over 5 pi. So to find what I'm finding here, you just have to be putting the number that is right here. So for example, 1, you put it where n is and solve. 3, put 3 there and there, solve. Here 5 there at n and solve. So we're done with this one. So now we can get this stuff, this one here. Let me write it here. It's f of x is equal to a naught plus summation of from n1 to infinity over a subscript n cos n pi x over l plus b subscript sine n pi x over l. So we can plug. Remember, we found our a right here, a naught, to be equal to 0. So meaning we'll write our 0 right here. You know that this is 0, plus this one, we also found it to be 0. Okay, plus now we have this one. So for this one, we'll start writing the coefficients. So we'll say 4 over pi. Okay, 4, we know that our b1 here is 4 over pi. And then we say sine, we get the sine which is right here. Sine, our n was 1, so if we put a 1 here, it won't change anything. Sine x, we know that L is pi, so this pi here and this will cancel. Our n right here is 1, so it won't change anything. Say plus. Our next is this. We have sine. This time around at n we put a 3, because when the coefficient is 4, or when n is equal to 3, our coefficient will be 4 over 3 pi. Okay, 4 over 3 pi. So meaning our n is a 3. This is the n. X plus this one will say 4 over 5 pi sine 5x, and so on and so forth. Okay, so we can clean up our work. We just say 4 over pi sine x plus 4 over 3 pi sine 3x plus 4 over 5 pi sine 5x. Okay, so this is the solution. Thank you so much. Kindly subscribe to my YouTube channel if you have not done so.